So what this video is going to go over is how to do your basic stoichiometry question, which is what I call a mole-to-mole ratio. And once you see this, you'll kind of find easier ways around this setup, but it is a way for you to understand what the balanced chemical equation gives you. So if I have nitrogen plus hydrogen gives me ammonia, which is called the Haber process. It's a very famous equation. This is essentially a recipe for chemists. So I have essentially a 1 in front of the nitrogen, a 3 in front of the hydrogen, and 2 in front of the NH3. Well, this tells me I need 1 mole of nitrogen to 3 moles of hydrogen to make 2 moles of ammonia. So this is essentially our cup. We speak of stoichiometry as being a recipe for chemists. So if I have 1 mole of nitrogen, 3 moles of hydrogen, I can make 2 moles of ammonia. Well, in most cases, I'm not going to have an exact amount of anything. So I need to do some calculations with this. So if I've been given 0.75 moles of nitrogen, not 1 mole, but 0.75, how many moles of ammonia can be produced? So what I'm going to do is I'm going to set up a ratio like we've done before with the mole. And this time, it's just going to look a little different because it's going to be based on the question at hand and the balanced chemical equation. So if I have 0.75 moles of nitrogen, how many moles of ammonia can be produced is what the question is asking. Well, I know from the balanced chemical equation that this is a 1-to-2 relationship. So all I have to do is in this proportion over here is put in that same relationship from the balanced chemical equation. So what number is in front of nitrogen is a 1. So 1 mole of nitrogen will produce 2 moles of ammonia. Okay, from a balanced chemical equation. Now again, most of you could see, oh, this is 1-to-2, I just need to double this number. And again, you're cross multiplying to get your answer of 1.5 moles of ammonia. Okay, and I know this is a little clunky, but this will help you with a more complicated problem that we're going to be doing, which is called gram to gram. Okay, but I need to see something, okay, when you do these problems. So if you want to write over on the side, okay, I have 0.75 moles of nitrogen, I know I have 1 mole of nitrogen for every 2 moles of ammonia, and you write down your answer, that's going to be fine with me. Or if you set it up a completely different way, as long as you cancel out units, again, okay, I just want to see that you get a final answer and I see some work associated with it. So using that same balanced chemical equation, let's try this one. So how many moles of nitrogen is needed to produce 4.2 moles of ammonia? So again, just like a recipe, we want to make so many brownies, we start with the product and work backwards. So that's all this problem is doing, but it doesn't matter who you're starting with, reactant or product, you always have the same relationship. So I could take the 4.2 moles of ammonia and say, okay, well, how many moles of nitrogen is that going to be? So all I have to do is set up my ratio. Again, from the balanced chemical equation, the number that is in front of the species is what goes in the proportion. Okay, so this one, again, you're cross multiplying, and then you're going to have to divide the 4.2 by 2. So you end up with 2.1 moles of nitrogen. So just to kind of show you another one, okay, but it's exactly the same relationship, it's just a different balanced chemical equation. So see if you could pause the video now and see if you could try this one on your own. So you should have ended up with 9.0 moles of nitrogen because I started with 2 sig figs, so I should have 2 sig figs in my answer. Again, I was given 7.2 as to how many moles of nitrogen. I have a 4 in front of the ammonia, and I have a 5 in front of the nitrogen. So that's a 4-to-5 relationship. So I cross multiply, and then I have to divide by 4 to get x by itself, I get 9. So let's try one more. How many moles of NO will react with 6.9 moles of ammonia? So you should have ended up with 2 sig figs here of 10 moles of NO. And again, your sig figs are wrong. So it's 1.0 times 10 to the first moles of NO. So that's kind of a yucky number just because we had 2 sig figs here. So all you're doing with this mole-to-mole relationship is taking a balanced chemical equation and applying it, okay? That's really the only purpose to it. And there's multiple ways of doing these types of problems. So if you don't like proportions, as long as you show me a relationship, that is all I'm looking